Hi, welcome back to this series where we are building a mini Rust in Rust. Obviously, things have gone a lot slower than I was hoping or expecting they would, because things are not easy. We can still only lex numbers, but we now have really pretty error message getting printed out. So if we're lexing some stuff like this, we print out all the tokens we've managed to lex. So lexing means taking this character input, splitting it up into different chunks of code that we're going to deal with later. But if something goes wrong, like we don't know how to handle an A yet in our code, we've got this nice pretty error message being printed out by the Miette library. So that's fine. But in order to get there, we hacked ourselves to pieces, and we've got like nasty code. So this is just our refactoring to make things nicer. We've got tests that cover our functionality. So now's the perfect time for us to refactor to make our code nice and keep our test passing. So the first and most egregious awfulness is that we've got this rule where every time we call next on characters, we also increase our character count by 1. And actually, technically, this is a byte count. So there's even some bugs in here that I'm hoping to fix at the same time. So what I think we'll do is we'll make something that is itself an iterator over characters, but also keeps track of the number of bytes through UR. I think that's what we're going to do. Yeah. Okay, so that means we're going to need a little struct called, it's kind of called characters, but there's already a thing called characters, right? Because that's what chars returns chars. So I guess we want, I don't know, clever chars. Like later this might also gain the ability to peek, although maybe we can use the existing peek code for that, not sure. So let's just call it ByteChars. So this is a class that provides the characters of a str and remembers your byte position in the str. And I guess it's going to hold on to a str. Whoops, I'm all capped. It's going to hold on to a str. So because this struct holds on to a reference, it's going to need a lifetime for everything it does. And we're going to implement iterator item equal. I think this is how this is going to work for ByteChars. And maybe it's not going to hold on to a str. Maybe it's going to hold on to a char. Chars. Yeah, I think it's going to hold on to a chars. Like this. It's still a reference, right? Because chars itself holds onto a reference. Like so. And we're going to implement... Oh, this is not... Yeah, that's not how you write that. This is how you write that. Char. And this should... you need to provide a lifetime here. Like so. So, yep. So what we're going to do when we're asked for a char, we're going to use self. We're going to use self.inner dot next. But before we actually return that, by the way, I always call this thing ret if I'm going to return it. Is that evil or is it okay? We're also going to remember our offset, which is going to be, I think it's just going to be a usize. It's the number of bytes. So let's just remember that as, why not just bytes? Right? And every time we return a character, we add to bytes And then for now, we're going to add 1. Then we're going to make a test fail. And then we're going to do more. So we're going to have some tests. I guess, should we just put this in a separate file? This feels like a separate file. So ByteChars. Maybe that's a terrible name. What's a better name for this thing? So it's going to go in there. We're going to write some tests for it. It's going to complain because it's not included. Now it is. So make some tests. So I guess the first thing is, like, you get given the characters when you ask for them. Iterating over ByteChars gives all chars, something like that. So that's going to be if I make a ByteChars. Oh, by the way, I can't make a ByteChars yet. So let's say we can make it from a string ABC. And then we iterate over that. And then we collect that. It's going to equal A, B, and C. Now, surely this is not going to be happy with me. I feel like it's not even compiling this code because there's got to be a load of stuff that's wrong with it. Yeah, it's not running this code at all because we haven't saved this file. Okay, fine. Yeah, okay. Yep. So now we've got some errors because it doesn't know about ByteChars. So let's just import super like I did before. We wondered whether it was okay. Right, now we need to provide, we need to import chars. We need to provide that constructor that we pretended existed. And that implementation needs the lifetime. And we're going to have a new, which returns self. And it's going to take in, I think it's going to take in, you're going to be able to construct it from a str. So that's the lifetime. There's where we're using the lifetime. And we're going to call chars on it. So we're going to create a self with an inner, which is inner.chars and bytes 0, right? And now we ought to be able to call into, oh no, oh right, yeah, I've done this wrong. This needs to implement into iterator, not iterator, right? No, it's already an iterator. That's fine, that's fine. Now it doesn't know how to collect it, so let's collect it into a vec. And now run our tests. And the test passes, which is bad. That means we wrote too much code before we did it. So what if we just return none? Then our test would fail, right? Yep, because we've got an empty list and we should have ABC. All right, so now our test checks that our code really works. And we're not checking how many bytes. So I think this is probably a good enough test for, like, maybe we should also test it like an empty string. Empty string gives empty iterator. Just in case we've got some bug in there on that. First of all, let's see it fail. It failed because this time it should be an empty string, and we were saying it shouldn't be. So now it passes. Fine. All right. So now we need to check that the byte counts actually work, right? So let's put the empty test first. So how are we going to test that we've counted the bytes correctly? Well, first of all, let's do counting 1 byte characters provides correct answer. And I guess what we want to do is create one of these things. Like so. That would better be mutable because we're going to iterate through it. And let's just assert at each step that the number of bytes that it's currently counted is correct. So when we haven't done anything yet, bytes should be 0. And I'm imagining there's a method here to get hold of bytes. And then we're going to call next on it. And now bytes should be 1. And we'll do that 3 times. And then let's just assert, just for the sake of argument, I think it's going to tell us that we should assert that this is none instead. So I think Clippy would tell us that is none is better. Yeah, I'm not actually convinced, but anyway. All right, so now we said there's going to be a bytes method. So why am I not just offering up bytes as a public thing? Just because I feel a bit queasy about that. We certainly don't want anyone to be able to modify it. So yeah, I'm not sure whether I'm being silly about that, but there we go. Now I can change my mind about how it's implemented later and keep this method going. Run the test. The test passes, so let's just check it fails. If I implement this wrong, because I was going too quick, wasn't I? Yeah, that fails, isn't it? And let's also look at if I don't increment this number, will the test fail? Yep. All right, so it looks like we've implemented a thing which keeps track of the number of bytes, or at least the number of characters we've passed by. But there is a bug, which is that it doesn't work with multi-byte characters. So let's use some counting multi-byte characters provides correct answer. So if we did A and then what's part of poo? I like to do part of poo. It's 1F4A9. And that is how many characters in UTF-8? 1, 2, 3, 4. Sorry, how many bytes? So the first byte is going to be at number 1. And then the next, after we've got the next character, it's going to be 4 bytes further on. And so on. So let's just have a thing here. Pile of poo is 4 bytes. And we failed because we treated it as 1 because we're not actually counting bytes, we're counting characters. So instead of adding 1 to bytes, what we should do is add something about ret, which is, oh, it could be none. So, oh gosh. If it's none, we shouldn't add anything to bytes, I guess. So we're gonna if let's equals ret. Yeah, so I think we didn't check what happened. That's a good point. Before we do this, we found a bug, I think, because the number of bytes shouldn't actually go up if you hit the end, right? So it should remain at 3 here, I think. and it failed. So now we can fix it. Take a reference to ret here so we don't break the fact that we're returning it later. But yeah, if there was some, if we did have another character increase bytes by 1, now we should have only one test failing. Yep, because only the number of bytes is wrong. And now we can add on something about R, like len UTF-8. That's it. Should be perfect. It works. All right, so what we've done is we've said get hold of the next character, increase my byte count by its length in UTF-8, and then return the character. So now we're keeping track of how many bytes we're stepping through. So all good. Let's make these public because we're about to use them. And the way we're going to use them is instead of calling input.chars, we're going to call ByteChars new, pass in input. We need to import it. And now we don't need to keep hold of character anymore because we're tracking the bytes ourselves, and it's going to be more accurate and a lot easier. Like so. And instead of us just taking in a reference to an iterator, we now need to take in a specific thing, which is, well, this is going to be chars.bytes. And that should be allowed because, oh, we can't pass this in anymore because we don't have it. What's wrong with that? Oh, bytes is a private function. I feel like my editor should help me more with that. All right, so actually we got away with not even changing the type that we pass into int, because int doesn't actually need to know that it's a ByteChars that we've passed in here. It's just anything that implements iterator is fine by it. So at least for now, we didn't need to change the type on that. But we've got this, because the type here is known, because chars is right here, we've got this bytes method that we can use. Now if our tests pass, that's weird. So what on earth have we changed that might, all right, yeah, we're giving, I guess we're giving the wrong, okay, there's a bug because we're giving the wrong answer here. I wonder why. Oh, I thought this was all going to be so straightforward. All right, which test is failing? We're saying 1, 2, and it should be 1, 1. Oh, maybe the -1 still applies. Is that really? Okay, it does. That's odd now. So, oh, I guess the point is, yeah, no, it makes sense. It makes sense. The number of bytes we've provided you with is bytes. So when you've called next a certain number of times, you've been given a certain number of bytes. And now there's an error in the last byte, right? So that's 1 less than the number of bytes that we provided you with. So I think that is fine. Okay, so now all our tests are passing. I actually realized I haven't done a commit. So we should definitely do a commit. But there's one more thing that I think fits into this video to fix. Now I forgot what it was. Oh yeah. So we did this aberration here where we broke out this chars.next and did it in 2 places. So let's not do that because we don't need it anymore because we're not manually counting characters. And we did the same thing in int. So we don't need that anymore. And that was making me sad. So now do our tests still pass? They do. All right. So I think we're now in a reasonable state. We have a lexer. It produces decent error messages. We have this hack that means that we're actually constructing a massive vector of tokens before we return it, which kind of undermines the point of returning an iterator from here. I think we'll tackle that next time. And yeah, we'll see what state gets mixed into that thing that we return, but we're going to return something that implements iterator. And like following the convention of like chars returns a capital C chars, probably lex is going to return a capital L lex, maybe, which implements iterator. And then once we've made that change in the next video, I guess we might start lexing things other than integers, maybe, if we're very, very lucky. All right, I hope you're still enjoying this. Well, if you're not, you've probably stopped watching. So see you next time.